Today topic of my presentation is E.M.F, that is electromagnetic induction. I will explain its definition, production, and types. Now let us start with its definition. Electromagnetic induction is the process of generating an electric current by moving a conductor through a magnetic field. It is based on the principle that a changing magnetic field induces an electric current in a conductor. This phenomenon was first discovered by Michael Faraday in 1831. What is relation between magnetism and electricity? The movement of a magnet can generate electricity, and conversely, the flow of electricity can create a magnetic field. Electricity is the force that causes charged particles to move around, while magnetism is the force that causes those charged particles to interact with each other. The two forces are so closely related that they are often considered to be two aspects of the same thing. Whenever there is a change in the magnetic flux linked with a closed circuit, an E.M.F is produced. This E.M.F is known as the induced E.M.F, and the current that flows in the closed circuit is called induced current. The strength of the induced current is independent of the strength of the magnet. The phenomenon of electromagnetic induction was first discovered by Michael Faraday in 1831. Now, what are Faraday's laws? Let us understand these by reading their statements. First law. Whenever the magnetic flux linked with a circuit changes, an E.M.F is always induced in it. Or, whenever a conductor cuts magnetic flux, an E.M.F is induced in that conductor. Second law. It states that the magnitude of the induced E.M.F is equal to the rate of change of flux linkages. The direction of the induced E.M.F is determined by the right-hand rule. According to this rule, if the thumb is pointed in the direction of motion of the conductor and the first finger is pointed in the direction of the magnetic field, north to south, then the second finger represents the direction of the induced current. The direction of the induced current will be such so as to oppose the cause that produces it according to Lenz's law. Induced E.M.F can be either I. Dynamically induced or 2. Statically induced. In the first case, usually the field is stationary and conductors cut across it, but in the second case, usually the conductors or the coil remains stationary and flux linked with it is changed by simply increasing or decreasing the current producing this flux. Here is a block diagram showing different types of E.M.F. In order to generate dynamically induced E.M.F, the magnetic field must be kept stationary while the conductor is moving. The equation for dynamically induced E.M.F is E equals BLV, where E is the induced E.M.F, B is magnetic field, I is the length of the conductor, and V is a potential difference. In the statically induced E.M.F, the conductor will be stationary and the magnetic field will change the induced E.M.F. Therefore, a transformer is a statically induced E.M.F since the conductor is stationary and magnetic field changes the induced E.M.F. Self-induction is a phenomenon by which a changing electric current produces an induced E.M.F across the coil itself. The phenomenon of self-induction is most important in alternating current circuits, since in these, the current is changing from instant to instant. And finally, mutual induction is a phenomenon in which the current flowing in one coil induces a voltage in an adjacent coil. This happens because the change in current in one coil causes a change in the magnetic field that affects the other coil. Mutual induction is the basic operating principle of electrical devices such as transformers, motors, and generators. Thanks for watching. That is all for today's video on E.M.F. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. If you want to see more videos like this, please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.